All right, good evening, everyone. I don't know how many people are here. If you're here, say hi in chat. If not, well, I'm just gonna commence with the Patreon Hangout. First things first, thank you for your support. As usual, if you're a $5 plus supporter on Patreon, you are invited to join live. If you're just any level of Patreon supporter, you will get to watch this recording. So yeah, I'll still try to answer everyone's questions. I did take a quick hi. Yeah, I did take a quick read through what was already posted. As always, live chat is also available if you want to ask stuff live. So, part-time Ronin, hey there. New room. This is just my office, my work space, basically. While we're at it, this guy right there, that is actually the big planter print from the CR10 that I was posting about on Twitter, etc. the last few days. So let's switch over here. Give me a second. Where's sound coming from? What is this? Audio input capture. Okay. Yeah, I just set up this OBS. Now we should have sound. Yes, we do. We do. Is that loud enough? Probably. Sorry. All right. So this is what it looks like. So this is Filamentum Vertigo Galaxy. This is their new particle filament, and it looks absolutely fantastic. Like, you know, hands down, it is a really great filament. If you're wondering why it is so glossy, there was actually, I don't know if you can see that right there, this section right there, 5 millimeters roughly. It's hard to show on pictures. By the way, the surface is not as inconsistent in real life. This is just because the light is at a really steep angle. But there was like a section that was dull and had a different surface finish. I don't know if the extruder acted up or if the filament got tangled or anything, but this just was bothering me. It looked really bad. So I took it, I took the clear spray paint to it, and you can kind of still see it right there. Yeah, it's a bit blurry, I'm sorry, but you can kind of still see it, but that really improved things, and also it created this magnificent surface finish. It is a fantastic print. So if you're printing particle filaments like Infinity Blue or Galaxy, Vertigo Galaxy or Vertigo Gray, try just hitting it with some regular automotive spray paint. That is going to give you a fantastic look. And if not, you've got a nicely clear-coated part. So let's jump right into it. So, all the questions first, as always. Francisco Bischoff. Why do I keep bringing up this pop-up? He's asking about carbon fiber composite filaments. So in particular, he has a... What? Wait, what? What am I my audio setup is 100% screwed up. I'm sorry. I muted my my headset, I thought, but what? Okay, I'll have to look into this afterwards. So let's start over with this question. Sorry about the technical issues. He's asking, Francisco Bischoff is asking about PETG plus carbon fiber and PETG. He has two different filaments from the same brand, and theoretically, PETG has a density of 1.32 grams per cubic centimeters. Carbon fiber is denser than that, but he's found that the PCF, so the carbon fiber plus PTG filament, has a strange low density. Doesn't say how dense it is exactly, but he does, or someone from the carbon fiber industry has the hypothesis that the composite has porosity, and that's why it has lower density. And he thought so. Yeah, this has been brought up before. This has been brought up somewhere. I don't know if it was on Twitter or somewhere else, but what he's writing here, it does make sense. So if you have a carbon fiber that is made with resin impregnation, like your typical carbon fiber part that has like the glossy, shiny surface, that resin is first of all injected at a very high pressure, and it is also a relatively low density, especially compared to molten or heated polycarbonate, PTG, plastics, thermoplastics. It does make sense that by default you have the fibers that aren't impregnated with anything. It's just the carbon strands, and you just add that molten PTG resin to it. It doesn't really fill up all the voids. So yeah, it does make sense that this wouldn't necessarily be a 100% dense part. It might still have some really microscopic air pockets in it. Also, what he's also saying, the carbon fiber in 3D printing filaments may not have real fibers, but microfibers that can be broken when you stop extruding. So yes, that is also very true. By nature, what our filament-based machines can do is not going to give you long continuous strands of fiber. If you want to see how that works, check out the Mark Forge Mark II or any of the Mark, I guess it's the Mark II and up machines. They actually do insert continuous carbon fibers, but they have a completely separate tool head to do that. With just a regular filament printer, you're not going to get any fibers of significant length. I think even like 0.2 millimeters is a stretch. That's probably quite a long fiber already for a regular printer. So yeah, you're not going to get that advantage of extra strength as you'd expect, and that is exactly what my Filoween tests have been showing. Carbon fiber filament doesn't give you the advantages carbon fiber typically gives you. It's more about the finish. Maybe you get a bit of extra rigidity, but you're not gonna make your part much stronger. So yeah, I guess I all I can do is confirm your All I can do is confirm your hypothesis, Francisco. And yeah, probably has some air inclusions, and it definitely isn't the long fibers you would expect from something that is called carbon fiber. Cool. Jonathan, I should remember not to bring those up, but Jonathan is asking about his building his own Delta, a monster Costal. It's beyond Costal XL size, bed roughly 350 millimeter diameter, and he's struggling to find a surface to print onto with that. So there are two components to that, two components to his questions. The first one is what material to make the bed out of, and the second one is what to put on top. I can speak from experience on the Cerberus Reborn, my 1 meter tall Delta. It has a 300 millimeter bed, roughly that size. That is 6 millimeter milled aluminum, so milled flat to perfection, and that stuff really is flat. If you have auto bed leveling, you don't need it that flat. So if you're using auto bed leveling and mesh compensation and all that stuff, you can just get your regular aluminum sheet material. It doesn't need to be anything special. Plop it on there, you're good. If you don't, or if you don't want to rely on that on a Delta, I don't know why you wouldn't. You do need something flat. So that can either be aluminum that's milled down or a sheet of glass. I'm not a huge fan of glass when I can avoid it, because it breaks and it doesn't conduct heat very well. So, and especially at that size, you do want it to heat up if you have a heated bed. You want to use as little power as possible. So yeah, either use glass if you're happy with that, or try and find some milled aluminum. Unfortunately, I don't know where he's from. but I typically find my milled aluminum sheets on eBay. They're not that expensive. They're less expensive than what you'd expect. The other question is what to put on top of it. So BuildTech does only comes in 300 by 300 millimeter sheets, leaving areas of the bed uncovered. And yeah, prints were sticking too well. I know that BuildTech really gives you a lot of adhesion, but you do have to be careful how you print with it. So yeah, if a 300 by 300 millimeter sheet is not large enough for you, why not just butt two of them up to each other, that they have a very straight, clean cut on their edge. You can just, use two. Totally works. If that's the material you want to use. The other suggestion I would have is use some liquid applicable adhesion modifiers. So 3D lac, the hairspray like stuff, Printafix, glue stick, Magic Glue, which of course are sponsoring Philoween, and which I'm personally also using a lot, simply because it gives you a really nice compromise of adhesion and release properties. Only works well for heated beds though, doesn't really stick that well for cold beds. For that, I'd recommend 3D lac, or if that's not available where you live, maybe go with the Aquanet Super Hold, which is the off-the-shelf equivalent. So yeah, if you can't find a big sheet of material, just go with something liquid. Gives you pretty much the same performance. Hope that's answered. All right, Volker Wegert, general question. And yes, we do have Volker Wegert in chat. Would it be possible to announce your other live streams here on Patreon as well? So not talking about a fixed schedule or complete TV guide for the next 3 months, but just a heads up. So little background detail for you there. My live streams aren't that, and neither are my videos, by the way, at this point at least, aren't that orchestrated and planned and worked out before I start. Often I don't even know when exactly I'm going to stream or what exactly I'm going to stream until I start preparing it, which is typically like 2 or 3 hours before the actual stream starts. And I just keep preparing and then announce it when I'm done, when I'm ready to stream. So that's kind of hard for me to do. I will try, at least 2018 and forward, I will try to be a bit more consistent with video uploads and with live streams. So at that point, we can think about announcing stuff. There is also, again, the guys from Magic actually pointed me to this. There is supposedly an online calendar where we have maker-related live streams that are just scheduled in there, and everyone can look those up. So that might be something I might be using, but we'll see. For now, I don't really have the the consistency to my live streams to be able to announce them. All right, Brandon Terry's asking, how do I feel about YouTube Red? Does YouTube compensate you for the loss as revenue, if like it was revenue? Because obviously YouTube Red is a service that you can buy for a monthly fee where you don't get any ads on YouTube, or I don't know, get a reduced amount. So yes, YouTube Red does compensate creators for basically the loss of ad revenue. And then if you go into YouTube statistics, let's just pull that up real quick. There we go. And by the way, these statistics aren't anything really special, because if you go on sites like Social Blade, they give you pretty good estimates of what a creator gets as far as views goes, as far as earnings go, etc., etc. So right up here in the 3 years that I've done YouTube, estimated revenue from everything. From everything, YouTube Red is about 10% or more than the pure ad revenue. So YouTube Red, 3,000 roughly, and that is that just the regular ad revenue. So you do get compensated as a creator for the ads that you're missing out on because people have bought YouTube Red. On the consumer side of things, I can't get YouTube Red because I'm in Germany. They don't offer that here. So I would buy it as a consumer because it's I think it's a really good deal. It's better than using an ad blocker, definitely. All right, Michael Kellerman is asking, hi Tom, would you mind printing a Benchy with a 0.25mm nozzle at 50 microns on your Prusa? He's been getting subpar results from the stock settings, I suppose, and not as nice as 150 microns. He searched and can't find anything. So I did have to look this up. Here is the wind. Crap. Okay. OBS is not picking it up, but I did look that up. So 50 microns is a default layer height on the Mark II. It is one of the presets. You can use it with either the 0.25mm nozzle or with a stock 0.4mm one. And to a certain extent, I do have to question, why do you need 50 micron layer heights? It is a pretty crazy layer height, and you're definitely pushing the limits of what your printer can do. Typically, like 100 micron is going to give you basically the same finish. So I personally don't see why you need 50 microns at all. But of course, that's up to you what you want to do. But yeah, that there is a certain limit to how low you can go. First of all, when it comes to mechanical precision, the Prusa Mark II obviously doesn't have the most high resolution z-axis, and when it comes to what your actual nozzle and extruder can do, so there is a limit to what layer heights are going to work with a particular nozzle size. So typically, I don't go below a quarter of the nozzle diameter. So 0.25, that would be math 75, bit less, 62.5 micron layers. So you're right at that edge. For a 0.4 nozzle, obviously that would be 0.1 millimeters, so 100 micron layers. That makes sense. And also the other thing is your extruder, which isn't a geared version on the Mark II, is going to run into a resolution limit. So the actual clicks that the motor can do, the steps that the motor can do, aren't going to be fine enough to actually give you a consistent filament flow. So if I had a 0.25 millimeter nozzle, I think I actually do have one somewhere. I would try it. I'll see if I can find one and try it, and just try a few different layer heights and see what it does. And also request on a masterclass on ultrafine printing. Yeah, I'll look into that. There's definitely a lot of room for content for next year. And just because it fits right here, so Pink Mouse is asking, go away pop-up. As printers seem to be getting better, especially the smaller format ones, should we be looking at changing the standard nozzle on these to 0.3 or even 0.2 millimeters? Just pondering the Obsidian news that they will be going on 0.3 millimeters as factory default. So fun historic fact, back in the days, how long ago was it? 5-6 years? Pre-E3D, E3D basically standardized the 0.4 millimeter nozzle as your default. But before that, you had two sizes. You had 0.5 and you had 0.35. 0.5 being like the coarser version and 0.35 being the finer version. And it was always a bit out of balance. Like the 0.5 one was a bit too coarse to be usable for everything, and the 0.35 was really good at reproducing details, but it was really slow to print. And eventually, people settled on 0.4 as a good compromise. Now, the thing with as I mentioned, the thing with smaller nozzles, especially 0.3, 0.2, is they take a long time to print, because first of all, you're not getting that width, that extrusion width, but also, as I mentioned before, because there is an optimum range where a certain nozzle size is going to work well, you're also going to have to lower your layer height. And this is something that plagues the PrinterBot Simple Pro, which comes with a 0.3 millimeter nozzle by default. It is a really slow printer in every regard. It's the files slicing and uploading is slow. Using the printer is slow, and then printing itself is also really slow. So I don't think we're going to be moving to 0.3 as a default soon. Yes, the options are there. You can always upgrade to that, but yeah, it doesn't make sense as a default. Actually, for consumer printers, for printers that aren't like high precision machines, I would actually suggest bumping it up to 0.45 or 0.5 millimeters just to give that extra speed boost to the machines. And you can still print at reasonably low layer heights. 0.15 looks good enough for most things. So yes and no. No, I don't see 0.2 or 0.3 becoming the new standard. Sweet. Paul Arden is asking, he's looking at going large like this. He likes the CR10's straightforward rigid design and is trying to decide whether to get one and mod it, or build from scratch, or look for alternative designs. From what he can tell, it's standard extrusion with solid V-wheels and a bunch of laser cut plates for base shape motion system. Yes, but of course he's liking building better than buying, which is basically my my taste as well. Now, the CR10, as with most Far East printers, it's good. The CR10 is surprisingly good of a machine. I'm actually running it right now. Again, it's printed this thing. It's printing another one in Infinity Blue. It is a really good printer, but it's not one that I'd start upgrading. And that is the problem with most cheap printers, and it's basically an idea that I've learned in RC cars. If you buy just a cheap kit that has everything, it's going to have all cheap parts. So eventually you're going to have to replace every single part to get a machine that is really, a level up, or you're always going to be stuck with, okay, this part is still cheap. This thing is still cheap. Like the CR10, the hot end works. It's not fantastic, but it works. The heated bed heats, but it's really slow. The electronics are okay. They work, but they're not giving you a ton of expansion room, and they're also like not the most highest quality parts. The linear motion system, yes, it's tight, it works, but it also wears down, and it's not really rigid. It only has one Z-axis spindle, so the entire thing just hangs down a bit. So I don't see the point of upgrading a cheap machine to be a premium machine. You might fix some flaws, but you're not going to upgrade it to a totally different level. So yeah, if you want to build something that either is really good, or that is good in all aspects, or build it with a few deliberate choices where you're saying, okay, I'm going to save on this part, and I'm going to upgrade that later. That's going to work for now. And I'm going to build everything else well. So that is something to keep in mind when building versus buying. But again, the CR10, if you're not looking for the greatest machine ever, it's a really good choice. And the second part of his question is V wheels, Delrin versus polycarbonate. Any views? By the way, yes, these V wheels, the open builds style The open builds style V wheels, they need to run on proper V slot, which is a different type of the T slot. If you run them on T slot, they're just going to wear down. They're not going to give you a ton of life, of usable service life, and they're not going to give you a smooth ride. So definitely get the V slot. And he's asking Delrin versus polycarbonate, any views? And yes, I would agree with what he's writing here. Delrin is probably the better choice versus polycarbonate. Polycarbonate might be a bit more rigid, but Delrin is just the right plastic to use. It is it's typically lower friction. It's harder wearing because it's a bit of, it's slightly self-lubricating. It's tougher. It's just the better suited plastic for that. Polycarbonate, yes, they're selling those as like these super rigid or something V wheels, which supposedly are stiffer and more rigid, but for a 3D printer you really don't need it. So yes, go with Delrin. Delrin works really well. Ewald is asking, do you have any experiences in combining flexible and rigid filaments in one print? So first of all, dual extrusion prints are tough to design. You do need to know your CAD system really well if you want to do a dual extrusion print. The other thing is you are going to need to find a printer that does flexibles and rigid materials. So something like, well, I guess something like the Prusa multi-material with a single nozzle could work, but you probably want something with 2 different tool heads. So Ultimaker 3, Sigma, other machines that have 2 separate nozzles. And yeah, if either nozzle prints flexible as well, then I don't see a reason why flexible plus rigid wouldn't work. Of course, you will need to try if your particular flexible material sticks to your particular rigid material, but most TPUs are really sticky anyways and are just going to stick to everything. So yeah, I've not done a whole lot of rigid plus flexible printing, but there's not much that can go wrong there. You just need the right printer for it. All right, few quick questions from chat. Lassie is asking, question, hi Tom, just wondering my filament layer adhesion choices. Just thinking of using a couple of filaments for my prints. I normally print 99% mechanical parts, and strength and layer adhesion are the most important things in my print. PLAs are nowadays quite good. And Lassie's thinking or considering using rigid ink PLA, which has good performance per dollar. It does. It has really good performance, and it's not that expensive. And he's asking what filaments to keep like as a basic stock, whether it's PTG, where he doesn't get any matte colored, and has other downsides. ASA, layer adhesion is poor, like ABS. Yes. What to start using? So for mechanical parts, in fact, I am printing a hang printer right now, which we will be building with Trinamic in December. And I'm using all PTG for that. I'm using E3D Edge, and I'm using a Printer Pro PTG. I don't know if they have a brand name for it, but it's 2 different PTGs. Good thermal resistance, or decent thermal resistance, good strength, really well printable. And along with PLA for like the more basic parts, I don't see that much use for specialty filaments anymore. Like ABS used to be a very common material. Now it's, compared to PTG and PLA, it is so much harder to print. It's not that much stronger. In fact, it is often a lot weaker than even PLA. The only upside with ABS or ASA is really you're getting that extra bit of thermal resistance. If you need that, keep some at hand. But basically, yeah, PLA if you don't need any thermal resistance. PTG, the stuff I print with most, and I still recommend it as a daily driver. Prints really well, is easy to use, gives you good strength, it's a really good compromise of everything. And then maybe if you need the extra resistance, keep some ABS at hand as well. I don't know where you're from, but one of my favorite choices is still Das Filament, German-made filament. They just moved to Bavaria, and they're really cheap for the filament they make. They make really good filament, and they're selling it at a decent price. All right, but international shipping from Germany is always a bit of a tricky thing. And Volker Weget is asking, did I have a chance to take a look at the Do It Smart Effector? Any comments? Haven't. The Smart Effector, that is, hold on, that's the one. Yeah, they showed that to me at TCT. Maybe we could bring that up real quick. That is a fantastic idea. Let's just switch over here real quick. So it's basically a delta effector that is, a PCB instead of anything else structural. And they're doing these as PCBs as well. Holy crap. And I don't know if you can see it anywhere, but it basically has a few strain gauges built in these areas. And you don't really need, you can't really see it, but this area has strain gauges built in. You don't need any sort of sensor for your print bed, because as soon as the hot end touches down, and this part right here deforms ever so slightly, your hardware is going to be able to pick that up. And yeah, it can sense that the hot end has touched down onto the bed. And that, I think, is a really great concept. It's good thinking. It is It's smart. It works well. It's light. I love the idea. I think it's a really great concept. I've not used it obviously, but I really like the idea. And also having all the connections here as as detachable connectors, as plugs, totally makes sense. Like, yeah, love it. And just to tie into that, where was that question? Yeah, this one. Benjamin is asking about building his dream 3D printer, and he wants to use it, do it Wi-Fi. And yes, I don't see anything speaking against do it Wi-Fi. It's really good hardware. It is well made. If if you can afford it, if that is within your budget, you really can't go wrong with it. Maybe one thing I would suggest is try out the firmware. Try to configure the thing before you get into it. See if it has all the features you want. They are really catching up to what to all the little carried over and legacy features, etc. that Marlin is now implementing, like the linear advance that's now coming into the more mainstream releases, stuff like that. If you don't need that, actually, Do It Wi-Fi might have that, the RepRap firmware. I don't know, but just give it a double check if you have all the features available there that you want. It does a lot of things. It does most basic things. Of course, and a few nice advanced ones. If you're happy with that, totally go for it. And he also wants to do an IDEX system, but not with a Bowden. So IDEX independent dual X-axis, like the Sigma has, two X-axes that can move independently, with direct drive extruders, Titan Arrow with Volcano plus Pancake. Yep, makes sense. Should be Cartesian. Yeah, it needs to be Cartesian for IDEX. Could also be a dual core XY. But yeah, the question is, does it make sense to be to not just do dual X-axis, but to also do dual Y-axis? And I think that is actually supported by Marlin at this point. You can do it. Now, the one thing I would like to point out here, I don't know how exactly you're going to build it and how complex it's going to make the entire thing. The one thing I do want to point out though is weight is less of an issue than you might think. I've built 3D printers that were overweight by any means, that were incredibly heavy on all axes, and they still printed incredibly well. To a certain extent, you do have to turn down your acceleration settings to match what the extruder can do. Titan Arrow is a high flow Titan Arrow plus Volcano is a high flow hot end, which is not going to respond as directly as you'd maybe want. So your extruder starts feeding filament, and it's going to take just a little while until your filament is actually going to start coming out of the hot end in a molten state. You do have to keep that in mind, and you can't like immediately, instantaneously, that's the word, start and stop your hot end. Even if you have a really good, strong extruder, it's not instantaneous. So you can't go as fast as maybe even your mechanics would allow. So you do need to step down accelerations and jerk settings just a tiny bit to get good quality prints, and that is exactly what the Mark II is doing, and Prusa's slicer profiles are doing, which means they work great on pretty much any printer. So I personally probably wouldn't go for the dual Y-axis. Benjamin is saying he's wanting to use a Titan Arrow plus Pancake slippers, which means it's going to be a relatively light setup, and I would first try a single X-axis or a single Y-axis, two extruders going back and forth, and then the independent X-axis, just because it sounds like a lot less of a headache than doing the independent X and independent Y axes. Yeah, Volker Wigget is pointing out, Do It 3D Wiki has a dedicated page for configuring multiple independent X carriages on a Cartesian printer. So yes, that is supported. And I don't know if the dual independent Y dual independent Y and X axes is supported at all. But yeah, I would not go down that route. Even if it's 500 by 500, you can build that relatively light and yeah, relatively rigid, and you can still have a good setup. What I would definitely recommend though is going with dual Y-axis motors. That is very easy to do, and just gives you that extra bit of torque and acceleration if you run into your motor's limit on that Y-axis. All right, cool. Fogabeta also pointing out configuring rep firmware for a hang printer. Yes, we are going to be using Marlin. We are going to be using a cheap RAM port because we will be using Trinamic chips, obviously, since it is a project with Trinamic. All right. I hope that answers all questions that you guys might have had. As always, thanks for stopping by. 35 minutes, good time. I think we covered everything. Yeah, what else to note? I did miss the second question to last. We did already answer that. A question about whether the smaller nozzles should be default. We did already answer that earlier on. Again, I don't think you should be using 0.3 as a default because it's just a lot slower than 0.4. It doesn't give you a whole lot of extra detail reproduction. All right. As always, thank you for your support. We did hit the. Let's just head over here. So yeah, where is that? We did hit the $2,500 per month goal a while ago. And yeah, I'll be able to hire a part-time helper. So when did we reach that? A while ago, I think. I did have an external video editor for a while that, was just doing on and off stuff, essentially working like a part-time flexible employee, but not having a person in-house just wasn't cutting it. So yeah, January 1st, I will be joined by a young Swede who will be working for me full-time. Not going for the part-time, going straight to a full-time employee. That is going to be fantastic. I'm really looking forward to that. Just all of this stuff on the side has taken up so much time recently. It's really going to be nice to have someone where you can just say, hey, you do that, and I'm not going to have to worry about that. That is going to be great. What else is going to be coming up? Yes, Volker Weger has pointed out that the Duet has TMC 2660 drivers, which is not the drivers that we're going to be using. We are going to be using the 2130 silent step sticks, which I'm working on a guide for right now. Not just using the Trinamic drivers, but also using the smart features like step loss detection and adjustable current and hybrid stepper modes where it combines spread cycle and stealth chop and all that stuff. That's what we're going to be what we will try using. Especially the step loss detection is something that the hang printer can really use. And yeah, I think that is going to be fantastic. And that's going to be the week of December 11th. That's going to be straight from Trinamic headquarters in Hamburg. All right. As always, thank you for joining by, and I'll see you soon. Have a nice day, evening, morning, afternoon, night, whatever it is for you. See ya.